3D printing has developed in the last 50 years, from a liquid metal technique for making prototypes to casual hobbyists using computer renderings to print plastic objects in their homes. Now, modern researchers are using 3D printing techniques with biomedical applications. We'll explore in the U.S. National Science Foundation's Discovery Files. Today's 3D printing is based on the concept of voxels, small cubes or spheres that are the basic building blocks of three-dimensional objects, the equivalent of pixels in a two-dimensional picture. The precise manipulation of these voxels when using bioinks is considered a grand challenge in biomanufacturing. NSF-supported engineers at the University of Virginia School of Engineering and Applied Science have developed a method for controlling these bioink-based voxels that could one day allow human-compatible organs to be printed on demand. This new bioprinting method is called Digital Assembly of Spherical Particles, or DASP. The technique begins with water-based bioinks being placed in a supporting bath to fuse into 3D structures that are suitable for cells to grow on. The hydrogel bioinks are mechanically strong polymers and highly tunable for mimicking the physical characteristics of human tissue. The technique lays the foundation for fully realized voxelated bioprinting. The potential applications include effectiveness tests for new drugs, disease and tissue modeling, and artificial organ transplant. To hear more science and engineering news, including the researchers making it, subscribe to NSF's Discovery Files podcast.